In this video, we'll do addition and subtraction of mixed numbers with different denominators. Our directions instruct us to add and write the answer as a mixed number in simplest form. So again, we're going to rewrite the problem and we're going to do it vertically so that we can pay attention to getting our common denominators ready. 3 2/3 plus 7 1/2. Let's look first only at our fractions. We have to find a common denominator between thirds and halves. And we know that's going to be sixths. So how do we get to sixths from thirds? Multiply by 2. Whatever you do to the denominator, you must also do to the numerator. That's the fairness rule, which I made up. It's not a real rule in math, but I'm going to call it that. The numerator, 2 times 2 equals 4. The same for 1/2. How do I get to a common denominator of sixths? Well, 2 times 3. Fairness rule. If I do it to the denominator, I must do the same thing to the numerator, and 1 times 3 equals 3. So 4 sixths, which is 2/3, plus 3 sixths, which is 1/2, equals 7 sixths. Don't forget about my whole number. 3 plus 7 equals 10. So that's a reasonable answer, 10 and 7 sixths, but I can turn this 7 sixths into a mixed number also. 7 divided by 6. It equals 1 and 1/6, which I am then going to add to the original 10 that I have. So 10 plus 1 is 11, plus 1/6. 11 and 1/6. 10 plus 1 and 1/6, which is what I turned 7 sixths into, equals 11 and 1/6. Let's look at a subtraction problem. 9 2/3, take away 1 3/4. My answer should be somewhere around 8, but let's see how the fractions make or change the number a little bit. Common denominator between thirds and fourths has to be twelfths. How do I get to 12? Well, 4 times 3, and 3 times 3 equals 9. Fairness rule. 3 times 4 equals 12. 2 times 4 equals 8. 8 twelfths minus 9 twelfths. Ooh, I can't do that and get a whole number, or I need to get even a fraction. I'd get a negative, and I don't want a negative. So I need to do some borrowing. I need to go and regroup. If I borrow from the 9, that would leave me 8 here, but I'm going to borrow twelfths. So 1 is 12 twelfths, and I already have 8 twelfths there. If you remember from other discussions, a whole number is the exact amount of numerator and denominator. 12 out of 12 equals 1. So 12 twelfths is the one I borrowed from here. 8 twelfths plus 12 twelfths equals 20 twelfths. Minus the 9 twelfths that I have here. 20 minus 9 equals 11 twelfths. Don't forget about my whole numbers. 8 minus 1 equals 7. So my final answer is 7 and 11 twelfths. And when I looked up here, I said 9 minus 1, 8 would be a reasonable answer. Is this pretty close to 8? Yes, it is. And the only difference I had here involved my fractions. The borrowing is a little bit tricky. Don't forget about it as you're doing your subtraction. It's no different than borrowing a whole, and then we are just switching it to match the denominator that we're working in. Let's do another example. 3 3/4 plus 9 2/3. Again, I have fourths and thirds, So I know 12ths is going to be my common denominator. 3 times 4, 2 times 4, 8 twelfths. It equals 2/3. 4 times 3 is 12. 3 times 3 equals 9. 9 twelfths equals 3/4. So I have 9 twelfths plus 8 twelfths, that's 17 twelfths. 3 plus 9 is 12. So I have 12 and 17 twelfths. Let's turn that 17 twelfths into a mixed number. I will have 1 and 5 twelfths added to the 12 that I already have. So 12 plus 1 and 5 twelfths equals 13 and 5 twelfths. Is that answer reasonable? 3 plus 9 would equal 12, and then I have the additional fractions, so 13 and 5 twelfths works. I hope this helps you with this skill. Good luck, and give it a try.